Hello! All right, we got a great video here. This one's about acceleration practice problems. So just like I suggested that you do at home to practice them, I just took the last 5 practice problems and then just switched the numbers around so we can get some extra practice. So you can do this on your own. You can take these 5, switch them around, make your own, which will give you extra practice. So number 1, while racing, I found I was moving at 100 meters per second after 10 seconds. What was my acceleration? So for this one, for number 1, we got to remember acceleration equals v2 minus v1 over t2 minus t1. So acceleration will equal 100 minus 0 over 10 minus 0. This one works out very easily to 100 divided by 10. This is meters per second. This is seconds. So acceleration will equal 10 meters per second, or 10 meters per second squared. All right. Number 2, using the information from number 1, how far have I gone in 20 seconds? So we know that the time is 20 seconds. So for number 2, we're looking for distance. So for the distance equation, I'll let you think about that for a sec. That's 1/2 AT squared. All right, so we know, or we're solving for distance, we know what the acceleration is from right here. So that'll be times 10 meters per second squared. And we know the time is 20 seconds squared. So how do we do that? You are welcome, as always, on these problems to do it with a calculator. I don't care if this isn't math class. While being able to do multiplication is important, that's not what we're doing here. So times 5, right? Because we multiplied 1/2 times 10 to get 5. 5 times 40 is about 2,000. And since we are solving for distance, we're going to leave it in meters. And all of these, this s squared, this will cancel out with that. So we're left with meters, which is what we see right here. Okay. Number 3. If I were to accelerate at this rate for another 30 seconds, how fast would I be going? So the only 2 equations that we have are this equation here and this equation here. So which one has speed? Which one has velocity in it? And that would be this one. So let's rewrite that here. A equals v2 minus v1 over t2 minus t1. Remember, I'm a big fan of rewriting equations, so you make sure you plug in everything that you have. So it says for number 3, if I were to accelerate at this rate, so this rate meaning 10 meters per second squared. So let's rewrite that here, 10 meters per second squared. We're looking for velocity, and it's for another 30 seconds. And remember, in problem 2, you went 20 seconds. So that'll be for 50 seconds total. So to isolate v there, we're just going to multiply both sides by 50 seconds, because that's what we have here. So if we multiply everything by 50 seconds, that obviously goes away. One of those s's will cancel out. 50 times 10 is 500 meters per second. Okay. I'm going to erase number 1. Let's do number 4. All right. Number 4, if I was traveling at 50 meters per second and then began to slow down, so this is deceleration, at a rate of 10 meters per second, how long would it take me to stop? So what are we solving for here if it asks how long? We're solving for time. We know that this is the equation that has time in it. Since we know what the acceleration is and we know the velocity, we wouldn't use this one over here because we don't know the distance. So we're going to use this one. So, sorry, I made a mistake there. I had to go back and fix it. We're going to start plugging in everything that we know. Okay. Looking at number 4, we've got a deceleration of 10 meters per second squared. So that'll be negative 10 meters per second squared equals, now our second velocity is 0 because we're slowing down to a stop. Our first velocity is 50 meters per second. And we're solving for time. Now, if we want to reorganize A equals V over T to solve just for time, we have AT equals V, divide both sides by A, T equals V divided by A. So we could even reorganize this so that T is equal to negative 50 meters per second divided by negative 10 meters per second squared. What we will be left with, since we're solving for time, the m's cancel out, 1s cancels out here. There we go. We're left with negative 50 divided by negative 10, so time will equal 5 seconds. For number 5, I'll leave that equation there to remind us. Number 5, how far would I go in that time period? So again, we're solving for distance. So d equals 1/2. The acceleration is negative 10 meters per second squared, and the time is 5 seconds squared. All right, so that will equal, d will equal negative 5 meters per second squared times 25 seconds squared, because the square applies both to the 5 as well as the s. That cancels out with that. Negative 5 times 25, distance will equal negative 125 meters. Now, why is distance negative? You can't really travel a negative distance, but what that negative sign is implying to somebody reading this problem is that you achieved that distance through negative acceleration in a time where you were slowing down. So I would totally accept an answer that says 125 meters, because distance can't really be positive or negative, but it does imply deceleration. However, if I was asking what is your acceleration and really you're slowing down, that needs to be negative. But distance and time, those time should definitely just be a number. Distance can be either, but acceleration should be either positive or negative depending on if you're speeding up or slowing down. Hope this was helpful. Send me an email if you got questions.